What is plasticity and material failure? Imagine bending a paperclip back and forth until it finally stays bent. That's a simple way to see plasticity in action. It shows how some materials can change shape permanently without breaking. When materials are stressed, they first stretch elastically, meaning they bounce back once the load is gone. But if the stress keeps increasing past a certain point, called the yield point, the material begins to deform permanently. This is what we call plastic deformation. Unlike elastic deformation, where the material returns to its original shape, plastic deformation means the shape change is irreversible. Plasticity is a key part of how materials respond to forces and eventually fail. For example, ductile metals like copper or aluminum can stretch a lot before breaking. When these metals are pulled, they first stretch elastically, then plastically, absorbing energy in the process. This plastic deformation helps spread out stress, preventing sudden failure. In contrast, brittle materials like glass or ceramics tend to break suddenly without much plastic deformation. They don't bend or stretch much before cracking. At a microscopic level, plasticity involves mechanisms like dislocation movement in metals. Dislocations are tiny defects in the crystal structure that slide when stress is applied, allowing the material to deform. In polymers, plasticity happens when long molecular chains slide past each other or break, forming small cracks called crazes. These crazes can carry load temporarily, giving the material some warning before failure. Understanding plasticity helps engineers design safer, more durable products. It explains why some materials can absorb shocks and why others fail suddenly. When designing parts that face repeated stress, knowing how much plastic deformation a material can handle is essential. It also helps predict how materials will behave under cyclic loading, where stresses are repeated over time. Plasticity allows materials to deform and absorb energy under overloads, giving warning signs before failure. This is why ductile materials are often used in structures where safety is important. They can stretch and bend, showing signs of stress before breaking. Recognizing how plasticity works helps us prevent unexpected failures and improve product design. In simple terms, plasticity in material failure is the ability of a material to undergo permanent shape change after stress exceeds its elastic limit. It plays a vital role in how materials stretch, absorb energy, and ultimately break. Knowing this helps us understand many mechanical failures and how to prevent them.